Well, again, thank you very much, Renata and everyone. And John, a really good talk that I think dovetails really well as we continue up the age spectrum. We know there's a tremendous number of high school students who are dual enrolled in community colleges. And I think that need to be thinking about data science development early and often is really critical. I want to acknowledge that much of the work I'm talking about today is with my collaborator, Ben Baumer from Smith College, who couldn't be here today. I've added links to the Etherpad to all the parts and pieces here, and I wanted to very briefly give you an overview of some of our work and our initiatives. So the data science core grants, many of you are familiar with. We have one of them to 9 institutions, 3 community colleges, 5 four-year colleges, and a university doing our assessment. The project has 2 goals. One is to foster experiential learning with community organizations, creating opportunities to scale up data science for social good. And the second goal is what really what I want to talk about today is trying to foster data science at community colleges. There's really, I'm not going to talk much, but I've given the links to some papers we've written about our work of how to develop data acumen for undergraduate students doing these research projects, using Scrum and Agile development techniques for data science. Again, those papers are available and the links are there. And that's really not what I'm going to be talking about today. That's pretty well done, that part of the project. We've learned a lot, and what I really want to talk about is how we can be building data science programs at community colleges, because this is critical for a number of reasons that I'll outline. So our goal is to really kind of think about motivating the importance of data science. This is a hard thing at present, given that community colleges have been slammed by the pandemic. If you look nationally, you see enrollments down 10 to 15%. The people who are kind of, students at community colleges have had the worst time of any, I think, in terms of dealing with the pandemic. And it's really sabotaged these community colleges' efforts to be able to kind of bolster new programs. They're struggling just to stay alive at this point. So we have to start by motivating the importance of data science and familiarizing leadership with some of the options that are being explored nationally. Renata, I'll talk about some of the programs that the South Big Data Hub fostered with the Keep Data Science Broad initiative now 5 years ago, and ways that those have built in various ways, but there's still a lot of work that's needed. But it's a really exciting time and exciting opportunities, which is why we're here now. Our goal is to help prepare faculty to teach data science, and by doing so, learning what the barriers and impediments are there. And we're seeing theirs are considerable. In summary, they don't have time and they don't have money. But again, there's a lot of initiative, there's a lot of motivation, really talented and engaged people. And a lot of the same kind of things I'm describing are the same initiatives I think we're seeing at some of our minority serving institutions and other institutions that have been historically under supported in our system. So really what we want to focus though on the student experience. What are the barriers for students to be able to pursue data science programs? They need to hear about this early. They need to be able to understand what their options are, and they need to have multiple flexible pathways to be successful with it. Our goal is to share resources and best practices. It's just a single grant, but we want to partner with others, and there are some really good people partnering. I'll mention briefly some EDC projects that I think are really outstanding. And then finally, kind of explore some next steps. So my goal today is just to try to give you a kind of a big picture of some of these questions, and then encourage those interested to kind of check in with us. Again, why community colleges? Goldie Blumenstick from the Chronicle of Higher Education describes them as the keystone for the nation's plan to help more people earn a post-secondary credential. I think they're absolutely critical. We know that there's a substantial fraction of our undergraduate students who are at community colleges. There are more people taking introductory statistics at community colleges than at four-year institutions. It's the only affordable game in town. There are some exceptions to that in various places, but when we think about affordable education, they're really structured in a way to really, foster that for people. And they're really critical to develop the educated workforce that we need. I think one of the points that came out really directly in the Keep Data Science Broad is that these institutions tend to be far more representative of the population than most four-year institutions. The number of first-generation students, low-income students of color are dramatically higher at these institutions. And when we talk about the need to expand opportunities for everyone, not just those who are kind of privileged, who've gone to, well-resourced school districts, this is an area, these schools are already serving these folks. And there's really a need for flexible and innovative articulation. That articulation is a key. When students take a course at community colleges, it has to transfer. Otherwise, it's a waste of time and effort that really may kind of cause them not to be able to reach their dreams and achieve their goals. So a couple of things I want to just mention, if you haven't seen them, the National Academy's report on data science for undergraduates came out. It defined data acumen, components thereof, and really talked about the importance of community colleges and the need for cooperation with other institutions. The link to the free report is given below. It's also in the Etherpad. As I mentioned, the South Big Data Hub and Renata and crew brought us together to talk about ways of ensuring that data science is broadly inclusive, that we don't repeat the issues that have led to the dramatic disparities we're still seeing, racial, gender disparities. We can't let that happen. We have to make sure as we design this new field, it remains inclusive and equitable. And there's a lot of work for us to be doing. I think we're making some baby steps, but we need to really double down in those efforts. That report, I think, helped highlight the importance. And the 2-year College Data Science Summit was funded by the National Science Foundation. It brought together a group of people to try to identify what was different at community colleges, how we can support faculty development curriculum initiatives, and also built on some of the results and findings from the Keeping Data Science Broad. So those are great background. If you haven't read them, I think they're really useful. I want to spend just a couple of minutes talking about what are some of the barriers and opportunities for transfer pathways. Again, I said we need a student-centered approach to foster success. We need to kind of be thinking about this in mind of how students are able to kind of proceed, what we need them to be doing, and how to structure and support them for success. As I said, they're motivated, they're engaged, but again, there's a lot of barriers in their place. There needs to be more of these associates to workforce programs. We're starting to see those. The Office of Personnel Management has put together kind of what jobs look like from the associates level. I think that's going to be happening over the next 3 to 5 years in larger numbers. My focus today is to talk about associates to transfer, to think about a 2-year degree that leads directly and seamlessly to a 4-year degree. So what are the points of friction we need to smooth or eliminate? I could talk for a long time about each one of the 5 that we've identified here. Let me just briefly introduce those. The first one is, we need a first course in data science to be taught at these schools. In order for any of these pathways to work, students must have an opportunity to take a first course in data science. They can't wait till they're juniors to do that if they want to develop sufficient data fluency and data acumen later on. And again, this ties in directly with the NASM recommendation that academic institutions should encourage the development of a basic understanding of data science in all undergraduates. This could involve a Joy of Data course, as well as a more technical one, like what we see in the Berkeley Data 8, but there needs to be a basic data science course. This course could be valuable for students in psychology or nursing or biology as well, to give them kind of basic introduction to their data literacy, but we need to make sure that's there. Most schools are still not offering such a course. There also needs to be a second course in data science. We know from a lot of the work that's been done that you need repeated exposure to develop more seasoned data acumen. And so, having just a single course won't be enough. One of the challenges here is that when you look at 4-year institutions, their second courses in data science are hugely heterogeneous. And we need to kind of make sure that there's kind of some clear understandings of what's transferable in there as a second course. But again, building on the basic data visualization and data wrangling that one might see in the first course. We see later on there's a need for a course that covers topics in scientific computing, data science workflow, and reproducible computing. We know that reproducibility and responsible workflow is a critically important part of structuring and organizing data science. We need people not to have to go on the streets to do that. It used to be people were saying, oh, learn GitHub. we're assuming it. Again, we found that leads to more disparities. We need to prepare students for the workforce, for kind of the big picture on undertaking data analysis. And these are skills that really need to be incorporated in the curriculum. Our fourth point relates to lab sciences. Many and all in Massachusetts of STEM transfer pathways from our community colleges require a lab science. And this is, not a bad thing. It would be even better, however, if such a course could build their opportunities to make meaning of data in these areas of physics, biology, or chemistry. And we could also imagine that a future data science infused lab course could be a really great way to build this in context in a domain area. Again, this is an area where there's opportunities within the constraints of the limited number of credits in an associate's program to kind of build deeper skills that include what would be traditionally lab sciences. Last but not least, communication, ethics, and application domains are critical. And so bachelor's programs, include explicit training in communication and ethics. This is a big part of what was incorporated in data acumen definitions from the National Academies. My colleague Ben has a great paper on how to structure a data ethics kind of program throughout a major, but we really need institutions to think carefully and holistically about how requirements for communication, ethics, and domain applications can be used to build credits that can be, successfully transferred in a flexible way. Closing thoughts of as part of the National Academy's roundtable on post-secondary data science education, which was focused on community colleges, two-year colleges, Uri Treisman described data science programs as powerful resources for students seeking upward mobility. And I think we owe it to those students to help create these opportunities in a way that really can allow them to be successful. So Ben and I have been working, and we believe that there's ways to make progress on these points of friction. They exist. There are challenges and barriers, but I think we can come up with solutions to make a lot of them more feasible. I put a link to a white paper that we've been developing that has more details and resources, and really hope you'll engage with this work. And again, I thank and I look forward to the conversations.
Thank you, Nick. Are there any questions directly for Nick? If not, I always have questions. First, before we do questions, Nick, how do people do people just directly reach out to you to get involved, or is there a project?
There are some projects. I'd be glad to kind of start with that personal contact. I put my email in there, and it's also in the Etherpad. But there are some groups that are working more generally on some of these issues. I think one of the challenges, though, Renata, is that we're fragmented. I'm seeing that on the K-12 data science side. There's a whole bunch of people doing really cool stuff in the learning sciences. Same thing on the math education side, the science education side, and the computing education side. And they don't generally talk to each other. There's not really a good mechanism to bring those folks together. And I think that's something that we need to be doing. There is a pretty active ACM community college group we've been in touch with. There's an active group with the Association of Two-Year Colleges Math Teachers, the AMATIC group. But this is a place where I think we need to kind of come up with some other ways to connect and support these folks. And particularly when we think about K-12, when we think about community college, we know the time, is not available for them. My job, I'm incredibly lucky with my job. It expects me to do things. And it provides me a teaching load and other kinds of supports, travel money to make that possible. I know there are many people without that. And in the world of community colleges, there's not the same kind of release time and other support. So we need to kind of figure out ways of both bringing people in and also kind of making sure their time is valued and supported.
For sure. Patty, yeah.
I was going to say that one of the things that I think it might be good for this environment is to understand that a lot of the students, I'm sorry that I don't have my camera on, but my bandwidth is low.
You're a little low too. Can others hear? Can you hear her?
Is it too low? Yeah, sorry. I'll bring up the, can you hear me better now? Is that better? Okay. So what I would say that like there's a lot of catching up to do from, and especially, you know, I mean, even though I am at a research institution, our students come with a very low very low background in math. And there's a lot of curriculum out there that they're doing in the high schools and K through 12 education that I feel would be really good to bring into like, and because it focuses on pedagogy, and it focuses on pedagogy that helps barriers, like helps people, enables them to be able to catch up and not feel like they don't belong. And I think that's one of the things that I think that maybe introducing a concept of pedagogy that increases a sense of belonging and camaraderie, so that people, instead of competition in the classroom, would be really, really good.
Patty, I agree completely with that, and a lot of the work that you've been doing. You had put in the link to the expanding participation in computing ESEP project, which I think has a lot of similarities to this. There are both questions about what we teach, but more importantly, how we teach them. And to do so in a way that's really inclusive, that's student-centered, is going to require a lot of differences for us. And the fact that this is now being taught in different disciplines. Amongst the 3 schools we're working with most directly in our grant, one of them is housed in a math department, one of them is housed in a computer science department, and another one is in an IT/IS department. And so again, we're also seeing business programs and the like. So there's a kind of a Tower of Babel that's developed here, but I think the principles, we know what's can be effective for students in terms of active learning, fostering a growth mindset, and there's really kind of work we need to do as instructors and as curriculum developers to really make that happen. It's great to kind of be seeing some of the projects and some of the other things going on, and that was one reason why I was looking forward to talking today.
Yeah, I think it's great what you're doing. It's so necessary. I just want to emphasize and encourage you to keep doing that, because honestly, I think one of the hardest things I had in Puerto Rico since I've been working here was convincing my fellow faculty members that lecture-based training isn't the best way, right? And so, like, if they see it happening, coming from a peer, there's no respect for that, right? They're just like, oh, who does she think she is? But coming from a collaboration, it makes a whole different, like, it changes everything. And so, yeah, I just wanted to emphasize how important this is. So thank you.
Definitely. And Sam?
Thanks, Renata, and thanks, Nick. Articulation is such a hard problem. And I know it really drives a lot of things at the community college level, but my question is a little bit outside of that. And it has to do more with positioning data science skills and experience in data science courses versus in disciplinary courses. And I know you've mentioned, right, STEM lab courses are a good setting for that. But I think the nature and the scale of the problem is such that we need sort of all hands on deck. At the undergraduate level in biology, where my experience is, we're doing a horrible job introducing, really foundational skills that would pay forward for students or reward those who have taken some computer science or really dug in on the statistics. So I know it's not quite to your topic today, but I know you've thought about these things. I'd like to just hear a little bit.
Well, it's at one point really vexing, but it's also pretty exciting. If we look at what's going on in the next generation science standards and how they've rolled out, and really thinking about a much more integrated approach to computation and data in the science curriculum, I think that's been very encouraging. We're seeing a lot of shifts in terms of providing support for statistics and data science in the K-12 curriculum. And I think there's a growth to kind of thinking about what these courses and programs look like at the undergraduate level. We can't afford to kind of wait until people get their master's program to be able to develop these skills. It's really kind of ensuring that they're getting them in high school and their associates, and then at the bachelor's level is going to be really critical. And I think we need to kind of be really creative about how we make that all work. One thing I think is pretty exciting was the approach that Berkeley took with their Data 8 course, and then designing a set of connector courses. There were 25 or 30 of them at its peak, I think, that tied in directly to the learning outcomes from that introductory course in linguistics and psychology and history and other disciplines. I think we could be thinking about courses that integrate computation and data, and to kind of be building on some of those kind of common things. This requires departments and programs never good at talking with each other to work with each other. And we need to then get the kind of cross institutional things going on. There are some examples. California is a great one where pretty much every course in the public school system has a mapping on the spreadsheet from here to here, and you can tell exactly where it transfers and how it comes together. These things take a lot of time, effort, and both bottom up and top level, top down things. I think it's particularly challenging because data science still is evolving. And so exactly what these things are not quite as well set as they are in biology. But again, I think that's the challenge for us, is to really kind of help support students for success in these areas by making them more directly accessible and transparent.
Thanks, that was really helpful.
Yeah, this is Mark. So during the academic year, faculty and teacher, they don't have a lot of time to get training, but in your grant, do you offer a program for teachers and faculty so they can learn and work on project, maybe small research project where they can learn new skill and then incorporate what they are learning in the teaching during the academic year?
If I'm understanding that correctly, Mark, and I'm pretty impressed from what I've heard about some of the programs recently in the NASEM technology and undergraduate STEM discipline. There were some really neat projects that were happening with research experiences for students from University of the Virgin Islands, and really innovative approaches that have been brought into the curriculum to give students that practice. What I think I heard from you was a sense of how do we provide such opportunities for faculty. Many faculty.
During the summer program. So the same way you offer REU, research experience for undergraduates, maybe we should offer these for teachers, research experience for teachers.
And again, I think we need to be doing that in all sorts of ways. We've seen ways that faculty development has scaled beyond the typical model of a small number of people in a room for a week or so in the summer. And we know that's, that workshop kind of approach is going to be a lot of shopping, not so much work. It's not clear what the outcomes are. But I think we've seen models for how the AP Computer Science Principles course developed a cadre of teachers that aren't your usual suspects, that are in much more diverse communities and a lot of much more under-resourced communities. I'm most familiar with what's going on in New England, where Microsoft funded 200 schools worth of kind of faculty development and brought them together. I think we've learned a lot of lessons from the pandemic of what some combination of in-person and then follow-up hybrid can do to allow people without kind of generating a lot of carbon and other things, and to be away from their families and things, to do remote instruction. And so I'm hopeful we can think about scaling such faculty development things. This would be a great NSF grant to kind of explore or to kind of be bringing together, because I think the world needs it. And I think there's a kind of a benefit for how we can be thinking about scaling these things up. That's going to require a team that involves many of the disciplines that are represented here today. And I'd be game to talk about some of those things if there's interest, because I know there's a need.
Yeah, so we're definitely interested in the faculty development piece. And I think most of you know about our Data Up program, which is aimed at faculty to do that used to be in person, now virtual, faculty development in like an actual hands-on workshop, but then also a pedagogical workshop that teaches about teaching data science and best practices in teaching. But scaling that even virtually, I think will require collaborators as we're thinking about the program, you know, you can still only have a certain number of people in a virtual room that you can actually have enough assistance to really answer everyone's questions and do what needs to be done to get people ready to be able to teach and not just a lecture style. So I really would be interested in how people are thinking through this, and if there is a larger grant that we can, you know, think about how some of these programs, the best practices have worked, what have worked for us, what's worked for others. Definitely in that space. I know there's another guy, Adam, who is just got a seed grant from the South Hub, and he's preparing. What he's doing this summer is doing a faculty workshop for middle school teachers. And so it's not faculty, it's middle school teachers, but from a broad range of different schools and different economic backgrounds of the school, and specifically physics teachers, to try to incorporate data science into physics curriculum, into physics modules in their middle school teachers. So that was one question, or I thought process around this limited capacity for new credits, and, you know, the limited capacity for new courses in K-12 and other things of specifically gearing towards disciplines. So we have 1 minute. So Patty, I'll say your question, and then Nick, I'll let you close us out with any of your thoughts as well.
I just wanted to say, and I actually wanted to thank the data. Am I cutting in and out? Or
You're cutting in and out. Yeah.
hold on. All right, does somebody else have a question, or am I the last one?
You
You're the
sound,
last. You
you
sound
sound
better now.
better, Patty.
Mhm.
Okay, I'm trying to switch to my phone. Hold on, let me see if I can switch to my phone so it stops doing this. Hold on. Just one second.
You sound fine. You can just
Oh,
go
I
ahead.
do? Okay, okay,
Yeah.
okay. Then what I was gonna ask is, so I wanted to tell you that data carpentry has served to teach people how to teach at our, this is, you know, a type of pedagogy. I think it could go a little bit further, but for starters, it did such a great job on our campus. And it's just really wild to see the professors like having confidence and actually seeing the computation needs to be incorporated in the science classes. And I guess I wanted to just to say, because like the person who at first was just like telling me, I'll just organize the, you know, the increasing, I think I mentioned this before, he's now got an ID gene, like he's gone into computational genomics, like just switched from what he was doing before into this new field and got an R25 in that field, and is developing, you know, basically science that is computational on campus and is like resilient to more resilient to climate change and, you know, electricity loss and things like that. The things that go on here, but I'm just to emphasize that that's such an important thing that you're doing, and in the Data Up program, just give it heads up, because that really, being able to train people in data carpentry to be and to be teachers, it makes such a difference.
That would be my closing thought, Renata, is exactly what Patty was saying. The data carpentry's approaches, I think, can help us kind of bring people up one level. And I think the aptly named Data Up program that you did really kind of helped build the communities locally and within the region. And I think those have really kind of continued to pay off in terms of what we need to do to bring the next generation of instructors into that. So thank you.